Today we're looking at bivariate data and regression. Up to this point, you have regularly drawn scatter plots comparing two situations. Common question in all sorts of subjects, life science, geography, and certainly in earlier grades of maths. So bivariate just means two variables. In this case, you can see there's a scatter plot comparing maths and English marks. The question said a headmaster was looking to see if there was a correlation. Remember, the word correlation just means, is there a relationship between the maths and the English marks? If you look at this particular scatter plot, one would certainly interpret that a poor maths mark goes with a poor English mark, and a good maths mark goes with a good English mark. If you look at this particular student at the top here, and you go down to the bottom, you'll see that the student has got just over 90% for maths and over 90% for English. So obviously one dot represents one student, and you can then go to each axis and read off their particular English and maths marks and compare them. We would also, in previous grades, have intuitively decided what kind of relationship there was between the two sets of data. So in grade 11 core syllabus, we decided, was there a linear, non-linear, perhaps parabolic or exponential graph that would show that relationship. In this case, most of you would have guessed linear, and in fact it's a positive correlation, because as maths marks increase, so do the English marks. What we want to look at this year is actually finding what we refer to as a regression line, or a line of best fit, or the least squares line. It can have any name. Basically, what we're trying to do is find a straight line. In this case, you'll see this is the line we're talking about, which has reduced the distance between each point on my data set and the straight line. So it's trying to take each of these distances and make them as small as possible. Now, you'll notice it's called the least square method. The square part comes in that if a point is below the line, like there, obviously the distance between that point and the line may be negative. And so obviously our square comes in because you want to make things positive. So that's going to help. Okay. I did not want to erase all of that. Okay. Obviously, a straight line equation is usually in the form y equals mx plus c, but you can see over here, it says that the equation we're looking for is, and it's that little cuppy on the y, we say y hat, is equal to a plus bx. Now that's the other way around to what we normally have, but do notice that it's, one would guess y equals ax plus b, but no, the a is the constant, which obviously is our y-intercept, and b is the gradient. That's important for just now. There are many formulae to find those values of a and b, and an example of one of those formulae is this biggie over here, where the b value, obviously that's your gradient, is given by n times blah, blah, blah. Now the bad news is this formula is not on the data sheet. Gotcha, you do not have to learn that. The good news is we can rely on our very old faithful Casio FX82ES. You're going to start by pressing the mode button. If you haven't got your calculator handy, you might want to just press pause and go grab it quickly. Obviously, if your calculator is updated or it's slightly different, it's not a Casio, try and work out the steps. These are obviously for one type of calculator, which is the one that we recommend. So start with mode, and you're wanting to select the stat option. In this case, it's option number 2. That'll take you to a new screen where you're looking for the a plus bx. Note the order of those letters. Okay, so remember, when you find a just now, following through your steps, that's going to be your y-intercept of your line, and your b is going to be your gradient. That will take you to a screen that looks like this. Okay, you should have seen that screen before. I'm sure we've worked with it in different sections. Obviously, down the left is your x and down the right is your y. In this case, those x values are representing our maths marks, and the y column is representing the corresponding English marks of that particular student. What you do is you enter all your x values first, so those are your maths marks. Press equals in between each value. Once you've entered all your maths marks, you go to the top of the y column and enter all your English marks in this case, or all your y values, pressing equals between each one. Once you've got to the bottom, you need to press the AC button, followed by Shift, Stat, and 1. That takes you to the Stat menu. Obviously, that's the statistics menu. And you will see you have the following selection. Obviously, it doesn't jump from 2 to 7, but the 7 here is the one that's important. If I remember correctly, it might be 5 on some calculators. I can't remember offhand. But you're looking for the reg. Obviously, that comes from regression. So we're looking for the regression line. Okay. When you select reg, it will give you the option of A and B. And obviously, you need both of them. So first select A, which is option number 1. Write down your value of A. In this case, it should be 13,54. You didn't have the table to start with, so practice on another set of data to double check that you are getting the correct answer. You then press the AC button again, Shift, Stat, 1, and then select the B to get your B value of 0,86. So run through that again. Once you've got your screen showing the one from type down to reg, you want the reg, so number 7. Select A first. Once you've written down A's value, press AC, Shift, Stat, and 1. It will take you back to the menu, which is going to give you the A or the B. This time select B, write down your value. So it gives us an equation with a gradient of 0,86 in this case, that was your B value, and a y-intercept of 13,54, that was your A value. The y hat comes in because this is, who decided to call it y hat, who knows, but it's an estimation. So this equation is used to estimate different English marks depending on what maths mark we put in. Okay, so if you want to know what a pupil could expect to get in English, if they got 55% in maths, we'll substitute their 55% into the equation and come out with y hat equals 60,84. So one could expect the learner who got 55% in maths to get approximately 61% in English. Couple of things you need to note. You may not use the equation the other way around. So in other words, you shouldn't substitute an English mark in to find a maths mark. You would have to find a whole new equation for that. Notice that we used the English as being the dependent variable and the maths as the independent variable. Notice which axes they're on. If you choose an x value that's within the values that we had used in our original data input to estimate a y value or English mark, we call that interpolation. See that word over there. But if you've had to extend beyond the values that we were working with, we can use this line, but it's not very reliable, often doesn't make sense, but that is called extrapolation. And the good news is, that's it for today. We're still going to do another little video clip on correlation, and we'll look at that just now.